Hi, my name is Chris Jobling. I'm a senior lecturer at the Department of Electronic Electrical Engineering at Swansea University, and I started to use Numbas this year as inspired by the last conference, and so I thought I would be brave and I would actually try and use Numbas for summative assessment for one of my modules, and this really is a report of what happened about that session. So I went about it using what I thought was fairly good practice. I developed an example test, which took a lot longer than I thought it would. There were quite a few issues that I needed help from Christian and from the group Google groups to get right. Still one or two issues around that. Then I thought I would get a couple of students to test that example test before I released it to the rest of the students, and I did get a lot of feedback from at least one of those students, with a lot of bugs were shaken out and corrected. I then made the example test available to all the students in the group, which is about 120 students, something like that, on a course called Signals and Systems, and we got a few more students trying things out and finding errors. One of the problems I had there was it wasn't easy to produce a new test version, because we've got a fairly old version of the LTI at Swansea, and I don't think regrading is possible with the version we've got, and so students wouldn't really get, if they were in the middle of a test and I upgraded the package, they'd have problems. So it wasn't ideal. So I tried to avoid updating too many times, and that probably made test a little bit more difficult for the students. Certainly there was a little bit of a lack of confidence, I think, by the time we went live. But anyway, from the examples test and the debugged versions of the questions on that, I developed a summative test, and we'll talk about that. Then on the 1st of June, we ran the live exam. So this was a 4-hour exam. They were allowed access to Numbas, and I said they could use MATLAB and other computation tools. And they ran about half an hour in. We started getting bug reports. There was quite a serious bug in some versions of the tests, obviously because students were seeing randomized questions. Not all students saw all of the problems, but there were a couple of problems that came up during the exam, which would have required regrading anyway. And the version of the LTI we've got doesn't allow automatic regrading, so that had to be done manually. I had some issues with regrading, so I ended up having to do the regrading actually in Canvas by sort of adding points back onto the grade that Numbers had replied, and I'll say a little bit how I did that. I did 100% regrading of the exam to sort things out. Aside from the couple of errors that I'd introduced, the main issues were around using different numerical accuracies. And in the end I sort of threw that away in order to give the students a reasonable grade. So there were a number of issues that came up. Some of them could have been anticipated, I guess, if I'd had more experience. Certainly there's an important message in that testing is extremely important and probably needs to start a lot earlier than I started it. But on the whole, I still want to continue with Numbers. I just maybe need to be more aware of best practice. So this is essentially got the presentation. It's going to be supported by recordings of various things from Numbas and Canvas. So I've got additional videos to add. But I'll talk about how I developed an example test, how I tested that using student help, how we ran it and got further bug reports. What a caveat there was not every student actually took the example test in advance of the real test, so there were some students definitely at a disadvantage, I would have said. Say a little bit about how I developed the summative test. Really just took variations of the questions that were in examples test and made them randomized. And the actual running of the test, and I'll explain the bugs that appeared at that point. And I'll say a little bit about how I did the regrading. So, I'll have a few comments at the end in summary. I'll start by just describing the design of the example test that I did first. So it's a conventional test. It's got 4 or 5 questions in it. And each one is a different topic. And looking at question 5, which is on the discrete Fourier transform. There's the statement and lots of variables. In the variables I defined all the Fourier transform requirements and actually computed a DFT for a sequence as part of the variable setup for that question. Question 3 was the most challenging one. This was on Fourier transforms, and I wanted to use j omega, which is standard way of representing frequency in electrical engineering. We tend to use I for current in our topic, so we tend to have the wrong kind of Fourier transform definitions. So for this one, often added a mathematical expression where the answer would have been something j omega, such as this one. So the answer is 2a over j omega for this particular Fourier transform. This is a slightly different one, sine t plus 1 over t. No, not many problems with that one. I had most problems when I did have the j omega term. So for this particular expression here, I needed to define a delta function, and I also needed to define j as I don't know if this is the correct way to do things, but that's how I tried to do it. And I had a range of omegas for the testing purposes. Sometimes it worked, sometimes it didn't. It was a bit variable, I found. Here are the functions that I defined, a delta function and a function representing unit step. Which worked quite nicely. To test it, I made the test available through Canvas, and I got a couple of team students to try things out about 2 weeks before I released the test to everybody. And I got a lot of bug reports from this example test, and you can see some of the bug reports actually in the text, the test to warn students coming afterwards. One problem I had with the test was if I found a bug, it was difficult to rerun it. I then made the example test available to all students, and a number of students tried it, set up so that they can have multiple attempts and everything. The problem was that students didn't completely engage with it. So looking at, these are the trials that people did, some did multiple attempts, but only about half of the students, less than half of the students actually did it. From that I went on to develop the summative test, which was basically based on those initial questions, variations of them. I had a number of variations for each of the questions 1 to 5, and they were chosen at random in the setup. So if you look at the computer marked test itself, it has random pick a random subset 1 question from a block for each of the questions that I had, and that looked like it was going to work fine, and it did. The actual mechanics did work fine. There were no problems with the test actually running at runtime. There were some issues though in some of the questions, which we'll go on to in a minute. To make it available in Canvas, use the LTI and set things up so that the students get just 1 attempt with deadlines set by Canvas itself. So here's some of the results of the actual test. You see 113 attempts by 112 students. So everybody had done this, although some students had not done the trial test at their disadvantage, I feel. Students only had 1 attempt at the test, and the results were collated by me. And I just had to remark it all. So, June the 1st arrived on the day of the test, and almost immediately, about half an hour in, we had the first error. And the first error is illustrated on this question. It's in question 2. The students are asked to do various things with simple impulse and step response. And in question F, they were asked to put in an expression for the unit step resulting from a particular system and a particular input. So the answer is of this form. It may not be the correct answer that's been hinted here, but it is of this form. And it's nice, you can see the numbers giving students feedback on what's right and what's not right, which is quite useful to the students, I think. So it's telling there's no matching bracket there. We complete the expression, adding this u naught of t, which is the unit step function. And this is where the problem arrived. So in the test, not before the test and testing, but in the test, this error came up. Variable x is not defined. It was relatively easy to sort out. The answer was that in my function definition I defined it as u of t, but I actually used x in the definition, so it's one of these errors you get by, and actually that's the expression I was expecting. It should have been correct, but the function that I defined was wrong because it had a t as a parameter but x in the definition. Easy fix, but too late to fix once the exam is running. So I had to basically tell the students to, if they had that question, to ignore it, and I would give them full marks, which is basically what I had to do. And you can see the problem when you correct that function, that error disappears. Had I thoroughly tested everything, I would have spotted that, but I was running out of time by the time it came to the test, and I'd done a lot of debugging during the testing phase, but there were still one or two things in the variations of questions which were wrong. See, there's no error in that one, although I've put the right expression in because I haven't taken care to put the right numbers in that example. Second error occurred was due to a gap fill problem. So this occurred in a couple of places. Here's one example of it, Fourier transform. I'm asking them to enter a Fourier transform value. And for this one, the first one is -2, but you can see it's repeated in all of them. I'm sure this is classic. It's basically because gap naught has been declared in the question. If the student had got one of those right, they would have got marks. Reduce marks if they didn't. So if you go back and just, so if I go back to, we can see what the problem is here. So this is question 5, and in question 5, as we'll see in a second, the gap question is set up wrongly. So gap, as you see, gap 0 is defined in each place, and so when you run it, you get this classic behaviour of the same number appearing over and over again. Very easy fix, but again, too late to do anything in the live test, so I had to give students marks. Students who had this question were given the corresponding credit. Easy fix, as I say, just make sure the gaps are correct. Defined, and the values come out of the calculations that I've set up behind the scenes. So should have worked fine, but didn't, and quite a problem. So once that's done, we test it, it works fine. Again, too late really to to put this over to the live running test. The students had already made an attempt. So all I could do was regrade and make sure that nobody was penalised for this particular error. And that brings us on to regrading. I did say, because this was the first attempt, that I would review all the marks when regrading, and that's what I did. I didn't realise that I would need to do quite as much regrading as I ended up having to do. So I had to literally regrade everything after the test had finished. And I did this in Canvas. So I would look at a particular student's submission, I'd review it, check whether the answers given were just incorrectly marked or actually wrong. And here's an example where the thing was wrong. We said that classic question with the bad value that I said. This expression here, this particular student had been forewarned and didn't bother attempting it, but that would have given a bad result. So I gave the marks for that. There are a few other things like missing brackets and things that students made in their formula that I didn't penalise. One thing I did find a bit unusual was I got a complex expression for one of the answers here, and the number came back as a number, and it was marked correct. So I don't know quite what that is. Maybe Christian can explain that to us. Something to do with the way the formulae are checked, I guess. So for a particular set of numbers for T, I would imagine the answer was 616. But anyway, there were a few anomalies like that. I didn't mark that down because I don't explain it. So you can see on this is some notes I made at the time of things that I corrected. Quite a lot, big list as you can see, of things that I needed to remark. So, in summary, I'd like to just pose a few questions. Is Numbas suitable for summative tests? I think it probably is, providing you take a few precautions. The main one that I found was you need to test again, and the more testing you can do before on questions similar to the ones you're proposing to make summative, the better you'll have. But there are some issues around Numbas itself, I think. It's a bit a steep learning curve. There are particular issues with equation marking which I couldn't quite sort out. I know there's a request in to make J valid as the complex, the imaginary number, for example. I know there are issues around that as well. The way I did it, I don't know if that's the correct way of doing it, but it seemed to work in some cases. But there were some edge cases in those questions which made them a little bit unreliable. Another thing that a lot of students did was, although the instructions said use omega for omega, they actually wrote W, and again that requires some additional cases to be added to the checking algorithm, I guess, but caused a few remarking as well. But the biggest issue, I think, that where I had to intervene most was in the numerical accuracy. There seems to be some difference between questions which have numerical values, where it's fairly clear how you set things up, to those questions where you're having equations and whether the parts of the equation should be particular values. I found some issues with fractions as well. Sometimes fractions would be okay, sometimes it wouldn't accept a decimal. So I think there are some issues around that which perhaps need to be addressed by the Numbas team, or at least documentation improved so that those people who want to use those things know what the restrictions are. But anyway, I used it. I'd probably use it again, maybe in a slightly different way. But it worked, in a sense, with some manual intervention. So I know what I need to do now. I need to start a lot earlier, and I need to make sure that everything is thoroughly tested. But I think, certainly for my kind of subject, Numbas definitely has a role to play. So thanks a lot. I will answer any questions in the live session.